I don't know about you, but I've been reading a lot about low-code and no-code code lately. There's certainly a lot of value in simplifying programming where we can. There's a blurry line though between what counts as software development and user programming or configuring an application. But what's the real deal with low code? Is this really the bright new thing that will do us all out of our jobs, or is it a retread of an old idea that's failed multiple times in the past? What are the things that you should be careful of when starting out with low code solutions, or in fact any software solutions, code or not? And what would it take to reduce those risks? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. And if you haven't been here before, please do hit subscribe. And if you enjoy the content today, hit like as well. I'd like to begin by thanking our sponsors, Harness, Equal Experts, Octopus, SpecFlow and Linode. They're all helping us to grow our channel, so please do check out their links in the description below. In this episode, I'm talking about some fairly fundamental ideas of how to make things work in software. Although it may not seem that low code is an obvious target for software engineering thinking, I think that it is. My new book, Modern Software Engineering, explains why in considerably more detail than I'm going to explain here, and the reviews so far are great, so do check it out. There's a link in the description below for that too. I've said here before that software is complicated stuff. It's complicated in lots of ways, and not all of them are obvious. Some of these complexities are easy to dodge. If we raise the level of abstraction, we can hide all sorts of detail. We don't need to worry about operating system differences, how stuff is stored, the details of complex things like user registration, or even taking payments perhaps. But there's another, deeper set of problems that you can't fix by raising the level of abstraction. Problems that are fundamental, inherent to dealing with information in information systems. So far, all of the low-code systems or no-code systems that I've seen ignore these problems altogether, and so fall foul of these deeper complexities. Let's start at the beginning. What is low code? Incidentally, I'm not going to keep saying low code and no code all of the time. I don't think there's enough difference to matter in this context. So let's just call them all low code systems. The idea is to make programming easier and more efficient. This is a valuable goal, and it can help people who couldn't otherwise write or construct their own systems to do so. Or to help people to do things more quickly and more efficiently perhaps. Let's be very clear about this. I have nothing at all against the principle of making the creation of software systems easier and more widely available. I think this is a very good idea. I just don't think it's as easy as it seems. The next thing to say is that there's nothing new to this idea really. In some ways, this describes the evolution of programming in general. What were the first compiled languages if not attempts to make programming easier than dealing with machine code? My bet is that machine language programmers in those days would have called COBOL programmers low-code programmers. But even if we don't want to include the evolution of programming languages in our low-code discussion, it's still not new. A spreadsheet is a low-code solution, a user programming solution for dealing with tabular data. Tools like these are enormously useful. But spreadsheets haven't replaced Java or Python, and they won't. Where low-code solutions shine is in limited, constrained problem domains. When the problem is narrowed down, they can be fantastic. I use several such systems in my business, for example. Unfortunately, every now and again, people selling this programming for all model forget this. I think that maybe we're going through one of these periods once again. They start to make grandiose claims for their tools that they will replace programmers and programming altogether, which is of course utter nonsense. It's possible that certain classes of programming may be done more easily with low-code tools, but no one will ever write a new operating system or a flight control system this way. No one will write an innovative new type of website like this either. Low code works best for problems that are already well understood and so easy enough to understand to be able to constrain them with automation. That's fine. There are different kinds of programming after all, and different tools make sense or don't in different contexts. The trouble is that it's not always easy to see when you cross the boundaries, even for experienced people, let alone for non-technical lay people who know nothing about the sneakiness of the complexities at the heart of software. One problem is that these claims that low-code solutions are the answer to everything are compelling at first sight. These tools nearly always look fantastic when you demonstrate them. I recall some years ago sitting through a lengthy multi-day sales pitch for some big enterprise service bus configuration tool. The idea of this system was that you could integrate your entire enterprise by visually mapping your process and the translations of data between the systems that it represented it. It looked pretty good. The demos clearly showed how easy all this was, except of course it was more complicated than that. What happened if there wasn't a one-to-one match of information flowing between the steps? We could create integrations as complex as we liked with their clever tools, said the salesman. Great, how do we test them? Silence. This is the biggest trap of all that no low-code system that I've ever seen so far has managed to avoid. Not just testing, but a completely naive assumption that the problem is perfectly understood before we start work and that we won't make any mistakes at all during the course of our implementation. Even if the tools are fantastic and hide us from the complexity, it's highly unlikely that we will be perfect. Even low-code tool users are still human beings after all. I use several low-code solutions in my own business, as I mentioned. My training websites and my mail list are each based on popular commercial tools. I use another to integrate them together. None of them support version control, automated testing, or even concepts like manual beta testing, where I could try out real-world integrations in a non-production setting. So if I make a mistake, I need to recall what the system was like before I made it, and then try to recreate what I remember of the working version if I want to undo the mistake. There aren't too many professional software developers that would make the choice to work like that these days. Imagine writing a programming language that didn't allow you to store your code in a version control system, and didn't allow you to run it in a test environment before release. The enterprise service bus integration system that I described, which was meant to be the glue that joined together all of the systems in your firm, it had the same problem, maybe even worse. Its programming was stored in a proprietary database, so you couldn't even copy the configuration of your system, your own program, without breaking the terms of the license. That meant that you couldn't test your changes anywhere but in production. This is simply dangerous nonsense. The mistake that all low-code solutions commonly make is that they don't support real-world software development. They all assume that we have a problem that we perfectly understand, that we will perfectly understand the tools and their use first time, and that we will implement everything perfectly. They make little or no allowance for mistakes, misunderstandings, or crucially, learning. I think that learning is a cornerstone of software development, and I mean that in several different ways, several of which impact directly on the usefulness or otherwise of low-code systems. I mentioned that I use a few such tools in my business. Recently, I found that I had an integration that I'd built that didn't work. Of course, this was my fault at some level, but I have some excuses. First, I'm a human being, so I make mistakes all the time. More specifically, in this case, I had a series of training courses on my training site, including several free ones, and I wanted to keep track of the people who signed up for the free ones and add them to a specific enrolled in free stuff groups. So I could offer them the next level commercial courses later. Yes, shock horror, I try to make this stuff pay for itself in part by selling training courses. They're very good, by the way. Anyway, I had 3 options for different events that I could hook up. It wasn't obvious which one was the right one to me. but two sounded like they should work and one sounded to me as though it was the wrong thing altogether. Surprise, surprise, the documentation didn't tell me what I needed to know, so I wasn't sure which one I should pick. I was also unsure about whether or not any of these would work for my case, so I picked what seemed like the most likely candidate and used that. The low-code software that I used to build this integration supported all of this. Probably better than most. It even tested the integration, so cool. It was a bit too clickety-clickety for my taste to set this up, but it seemed to work, except that it didn't. Checking back later, no one was added to the appropriate mail list group as I had hoped. I went through and tried the next likely event and waited for some sign-ups. Again, got lots of registrations and no one in the mail list group. Eventually, after contacting the support organisation from my training provider and asking why don't I get an event for registrations on free courses, they told me that the event I was sure couldn't possibly be the right one was the right one. I changed it yet again, waited for some results, and this time it worked. Could I have written and tested the code faster? I'm not really sure. I've left out quite a lot of messing around trying to figure out which part of the system wasn't working, so maybe. Each iteration of this exploration took a fair amount of albeit fairly trivial work. I had about 10 integrations that followed exactly the same pattern in all, but each was separate because that's how the tools work. No notion of a function or a class here. At least not a user-defined function or class. So no modularity. It's not really a consideration for the users of this system. I was dumb, sometimes I am, and I created all 10 integrations together before testing that any of them worked properly. Had I written code, I would have assumed that this was a bit more complicated and so worked a little bit more defensively. The low-code tools made this look a little bit easier than it really was, so lulled me into a false sense of security. Plus the tests inside my integration tool showed that everything worked, except it didn't. The user interface for my integration tool is web-based. Its integration was around 5 or 10 pages, 5 to 10 clicks, and maybe a bit of typing in each one. Let's say 5, so I'm not overclaiming. For 10 integration, that's 50 interactions. When it didn't work, I leapt to the conclusion that it was obvious what the right answer was. Use the other event type, discarding the one that was clearly wrong. Annoyingly, that's another 50 clicks. I wasn't allowed to only update the bits that needed to change, so no cohesion or good separation of concerns here either. Guess what? That didn't work either. It turns out, as I said, that the event that I really needed was the one that I was sure was wrong. That one actually worked in the end, but it cost me yet another 50 clicks. So, lesson 1. Maybe I should pay more attention to my own advice and apply my preferred experimental approach to this low-code stuff too. At no point in this process, if I'd broken things worse than I did, could I have stepped back to safety, except by remembering what working looked like. This is just about feasible for 10 simple integrations like this that were all fairly similar. It's not feasible for systems that get much more complicated than this though. There was also no way that I could find of tracing the flow of events to see where the problem was and to diagnose it. No logs that I could access, for example. These are the kinds of problems that always happen in software. A dumb programmer, me in this case, makes a mistake and ends up with a bug in production and needs to fix it. Where are the tools to help me safely correct the mistake? The problem itself wasn't the fault of the integration tool. It was completely outside of it. So there was no way for that tool to sensibly predict this kind of problem and so automate to abstract that problem away or test for it. What professional programming tools and languages do is to assume that these sorts of things are going to happen and provide support for those times when they do. We have tools that help us to design better compartmentalized systems so we can gain the benefits of reuse Tools like functions, modules and classes. Tools to determine what's going wrong, like logs and debuggers. And tools that allow us to identify and recover from mistakes, like testing and version control. Here's a quote from the Squarespace website. Squarespace is a draw your own website kind of tool. By most accounts, it's very good. But if your advice is you don't need version control if you're working alone, then you've either never written any real code or you've never made a mistake. In either case, you aren't qualified to offer advice in this area. And for me, that's the real problem. It's not that I hate low-code solutions. I don't. I use them. Or that I'm fearful for my job. I'm not. It's that there is often a degree of conscious or unconscious overplaying of the power of low-code systems and underplaying of their risks. At its heart, this takes the form of assuming that the act of creation in software is the difficult part. I think that this is a very naive view of what software development is, and of why it's difficult and so expensive. If you think that your real job is to translate fully formed ideas into code, then I recommend that you take a look at GitHub Copilot. It may make you fearful for your job. Software development is more difficult than that. Even low-code software development. We solve problems for people using software. A fundamental skill in being able to do that is to learn enough about the problem to think of some solutions that may work, and then to experiment with these ideas to see if they do in fact work. For that, we need the tools, understanding and experience of software development. We need log files and error handling, version control and the ability to write tests. We need the ability to test ideas before they exist in production, and we need the tools that allow us to make progress incrementally, giving us the ability to step back from mistakes and correct them without relying on our imperfect ability to hold the whole system in our heads all of the time. We need tools to manage the complexity of the systems that we build. Low code tends to ignore these problems completely. And until it does address them, then they only make sense for extremely simple common cases. The problem for professional software developers like us is that it's not obvious, even to us, let alone to non-technical people, where the boundary lies. What counts as simple? Is 10 integrations of 5 pages of stuff simple? Well, maybe. Is integrating a fleet of enterprise systems simple? Certainly not. This is clearly beyond the competence, or should be, of these sorts of tools. There is a lot of grey area between these two extremes. How we organise our work is important to doing a good job. Over decades of evolving tools and practices to support us, software developers have learned some things that matter. The huge risky mistake that I see low-code solutions make is not building these fundamentals and their learnings into the approach. The trouble is that they start to look more complex then, a bit more like regular programming, so aren't quite as easy to sell. The big danger, as I see it, is that many of the people that buy these things don't know enough to realise just how thin the ice that they are skating over really is. Thank you very much for watching.